Hello everyone, I'm back with another stream. Today we're going to be going over more in-depth tutorial over unit testing. We've been building a dice roll app for the last few streams, and we're going to be going over a code lab from the official Android development site that will help us to learn about unit testing. And so if you're new here, please subscribe, and I really hope that you learn something interesting because this whole channel is the quest of helping you become a pro Android developer. Without further ado, let's go ahead and get started with our stream lesson for today. And I'm going to go ahead and mute the music here, and let's go ahead and go to our code lab. And all right. Before you begin, in previous code labs, you learned how to create a project with Android Studio, modify XML to make a customized UI for your app, and modify business logic to add functionality. This code lab focuses on why testing is important and expands upon unit tests. You get the opportunity to see what they look like and how to write them. Prerequisites: you have created a project in Android Studio, you have experience writing code in Android Studio, and what you'll learn: why testing is important, what unit tests look like, how to write and run unit tests, and what you'll need: a computer with Android Studio installed, the project you created in the previous code lab, in this pathway. So this is okay. So that's a link to the previous pathway. So so it would be good to have the code for the previous code lab. If you don't have the code, you should get the every code lab has a solution code. So I would go to the previous code lab, which would be, an easy way is to go to the previous video I have up and go ahead and get the code, the solution code from there. And that's a good way to get started really quickly. All right, number 2, introduction. Now that you've written some Android code, it's a great time to follow up with some test code. First, you go over some philosophy on testing, to dive deeper into the auto-generated test and Android project, and lastly, write your own test for the Dice Roller app. This lesson covers a lot of material, but don't be intimidated. Take your time with this material because testing takes a long time and a lot of practice to learn. Don't be discouraged if you don't get a handle on it right away. Why is testing important? At first, it might seem like you don't really need tests in your app. When your app is small and has limited functionality, it's easy to test it manually and determine if everything is working correctly. However, as your app grows, manual testing takes much more effort than writing automated tests. Furthermore, once you start working on professional level apps, testing becomes critical when you have a large user base. You must account for many different types of devices running many different versions of Android. Eventually, you reach a point where automated tests can account for the majority of usage scenarios significantly faster than manual tests. When you run tests before you release new code, you can make changes to the existing code so that you avoid the release of an app with unexpected behaviors. Remember that automated tests are tests executed through software as opposed to manual tests, which are carried out by a person who directly interacts with the device. Automated testing and manual testing play a critical role in ensuring that the users of your product have a pleasant experience. However, automated tests can be more precise and they optimize your team's productivity because a person isn't required to run them and they can be executed much faster than a manual test. A closer look at unit test. In this code lab, you focus on unit test. You cover instrumentation tests later on. To start, you look at the tests that are generated when you create an Android app. Through Android Studio, you also get some hands-on experience running the test and gaining some familiarity with writing test code. In previous pathways, you went over where to find source files for tests. Unit tests are always located in the test directory. Open the app Gradle build.gradle file and look at the dependencies. You see some dependencies marked as test implementation and Android test implementation, which correspond to unit and instrumentation tests, respectively. Of note is what they're talking about. Let's go ahead and go to our Android Studio, and it's saying to go to our Gradle files, or pretty sure it said the app.gradle, which is here. Well, actually, maybe it wants us to go to the module Gradle here, and then it wants us to look for test implementation. So down here is our dependencies that are added for JUnit, and probably here Espresso is for the instruments test, which is also known as a UI test. But today we will be focusing on a unit test, which is this JUnit dependency that is included there. The JUnit library that drives your unit test and lets you mark code as a test so that it can be compiled and run in such a way that it can test app code. 2. In the test directory, open the example unit test.kt file. You should see a sample unit test that looks like this. Example unit test.kt. So every time you make a new project, it will automatically generate a new folder for you that is for the unit test. Oh yeah. And also I'm gonna go ahead and post this collab in the chat so that people can be able to follow along as well. So let me go ahead and do that real quick. Code above is code lab we are going over. All right. And then so what we can do now is we can go to our Android Studio, and then inside our Android Studio we should be able to find the test. The Android test is this will be for the UI test, but for the unit test will be under this test here. So this is our test unit test right here. So while you added some code to the Dice Roll app, you likely didn't write any tests. As such, there's nothing but some generic code that's created automatically by Android Studio. This is an arbitrary test that serves as a placeholder for more relevant tests that the developer is expected to write. Currently, this block of code only tests that 2 plus 2 equals 4. Of course, it's always true. Take a closer look at what's happening. Test functions must first be annotated with at test. Annotation imported from org.junit.test library. You can think of annotation as metadata tags for a piece of code that can change the way the code is compiled. In this case, the at test annotation lets the compiler know that the following method is a test, which lets it run as such. So, so inside our Android, um, there should be an annotation saying test. This is required for our unit test function, and, and then following the annotation, you have a function declaration. In this case, addition is correct function inside the function. The assert equals function asserts that an expected value should equal an actual value obtained through business logic. Assertion methods are the end goal of unit test. Ultimately, you want to assert that a result obtained from your code is in a particular state. If the state of the result matches the expected state, the test passed. If the state of the result doesn't match the expected state, the test fails. In this case, the code is comparing two values. So the assert equals method takes two parameters, an expected value and an actual value. True to its name, the expected value is what you expect a particular result to be, in this case 4. The actual value represents the result of an actual piece of code. Generally, this would test a piece of code from the app itself. In this case, it's only an arbitrary piece of code. For example, 2 plus 2. Without further ado, run this test to see what happens. so yeah. So when we go back to our Android Studio code here, it's saying assert equals. So it's passing in the expected is 4, and so this code is 2 plus 2, which is the one being tested. Does this code reach this value, which is expected? So when we run the actual unit test, we will see if 2 plus 2 is indeed 4. So, alright, so yeah, it says test results, success. This green check mark means success. And, alright, what if in our code we have 2 plus 4? Is 2 plus 4 equals 4? Will that pass? Let us see. So, alright, so we had a test failure. Test failed 1, expected 4, actual 6. So that's how that works. And then you have different methods here. There are many assertions in the JUnit library. Some common assertions you might encounter are assert equals, assert not equals, assert that, assert true, assert false, assert null, assert not null. And for more informations on assert, you can check this documentation here, which I'm going to also post in the chat so that people can follow along. And remember, I also make sure to post this in the comments for anyone watching the recording. So, all right, so the above link gives more information on JUnit asserts. Awesome. Awesome, awesome. All right. Now, going back to our lesson, there are many ways to run tests in Android Studio, which you dive into later. Now you keep it simple. Next to the addition is correct method declaration, click the arrows, then select run. This is is referred what is referred to as a positive test. In other words, the assertion is the affirmation 2 plus 2 is equal to 4. Alternatively, we could write a negative test, which makes an assertion in the negative. For example, 2 plus 2 is not equal to 5. In the run pane, you should see something like this screenshot. Okay, so when we go to our Android Studio and then we run it, which our last test was unsuccessful. So we ran it again, and of course it's unsuccessful. And make sure you choose this tab, the run tab, so that you can see the output of the test, which is important. If you try to do logcat, you won't be able to see the results of the test, so you have to choose run down here in order to see the results of the actual test. So keep that in mind, which is different from when you run the app. Usually you'll see like things in logcat. Yeah, but in this situation you are under the run tab. And then it says modify the test to see what a failure looks like. Change 2 plus 2 to 2 plus 3, then execute the test again. Keep in mind that you're only experimenting with the generated code to gain experience with how tests work. These changes don't hold any relevance to the dice roller functionality. After which I've already showed you guys an example of what it looks like when we change it. So after you run the test, you should see something like this screenshot. The red text indicates a test failure. In the menu of test results, clicking on the items in the items in the box provides an error message that indicates why the test failed. So it indicates why the test failed. The expected was that. The actual was this. And let me see something. So when we go to our actual code here and we click the differences, it shows a file that compares the two values. And this assert failed on line 15 when you click this uh, link inside the error. All right, so let us go on. In this case, the message indicates that the assertion failed because it expected a result of 4, but the actual was 5. This makes sense because you changed the value to be 2 plus 3, but you left the expected value as 4. You can also see the line of which the test failed. In this case, line 15, denoted as example unit test.kt 15. 3. For the sake of thoroughness, change the expected value from 4 to 5 and run the test again. The test should now pass as expected. Value matches the actual result of the code in question. So pretty much the equivalent of that would be me going back here, and then I change this to 4 plus 2. 4 plus 2 is 6. So actually we are expecting 6. So now that we are expecting 6, will it actually pass? So let me go ahead and play this, the unit test, which there's an arrow right here by the unit test lab or the class, and then I run our function, the unit test right there from this side panel here next to the class. Not up here, that's running the app, but down here by the class here. And then we ran it, and then boom, test results success. All right. And we don't get any errors right there, which is good. So let's go back to our test. And now it says, write your first unit test. Now that you've gained some comfortability with unit tests, you can write your own unit test that's more relevant to the Dice Roller app. As you've already noticed, the Dice Rollers app primary functionality is based on a random number generator. Unfortunately, random number generators are notoriously difficult to test because you can't be sure of the outcome of a randomly generated number. The goal of this test is to ensure that when you roll the dice or call the roll method on the dice class, you get an appropriate number back. The test you write simply tests that the output of the random number generator is a number within the range you specified to the generator. 1. The example unit test.kt file, delete the generated test method and import statements. Your file should now look like this. So let's clear out the current UI test there, which is the example test. So I'm gonna go ahead and delete this addition, and I'm gonna go ahead and they said they want to delete the imports too, so I'll go ahead and delete the imports. Oops. And then let's go back to our lesson. Alright, so we have done that. Alright, and then, alright. Okay, it says, so create a generate number function. So we're going to go ahead and create a generate number function inside our example unit test class, which when we go back here, we're going to go ahead and add this to this class, which is generates number. And then what else? And then it says annotate the generate number function with at test. So we gotta add this at test to the beginning, because we need to do that when it is indeed a unit test method. So we're going to go ahead and add that before our function. Then make sure you import the necessary requirements that it asks. And so, okay, we imported this junit.test. All right, and now, since we annotated this with the test, it knows that this will indeed be a unit test. So we went ahead and imported that. Alternatively, you can also copy and paste the import org.junit.test file after the package name, but before the class declaration. The code should now look like this. So, alright. So we imported that, like I said, and added the function here, like I said, with the annotation of test, like I said, and for create an instance of the dice object. So now what it wants is an instance of the dice object. So we're going to create a val dice equals, we're going to set the dice to 6. Alright, so let's go ahead and go back to our Android Studio. Then in here, we're going to go ahead and make a val dice. Then it's going to be dice set to 6, which is going to be a 6-sided dice. Alright. And then let's see what it says back at our lesson. Next, call the roll method on this instance and store the return value. So I'm going to call the roll and dice.roll. So we're going to go back to our Android Studio. Then we're going to go over here. And then we're going to do a result dice.roll. And then finally make an actual assertion. In other words, you need to assert that the method returned a value that's within the number of sides that passed in. So in this case, the value needs to be greater than 0 and less than 7 to accomplish this to accomplish this. Use the assert true method. Notice that when you try to call assert true method, the text is red. This is because it can't find the declaration of this method as you need to import it. Similarly, what you encountered with the annotation. So, for instance, we're going to try to call the assert true. And then, so when we go back to our Android Studio, we're going to actually go over here. And we're going to say assert. Let me see something really quick. So it says assert true, which we try to call it, but it's going to give us something in red. So we have to import that. and then org.junit.assert. So we highlight that, import org.junit.assert, which we import from that. Then it looks like we have to have a boolean or a string and a boolean. So what do they have here? So we included that, and so assert true. So we're gonna add this here to assert true. The value of result was not between 1 and 6. So we're gonna go ahead and take this line. It looks like it compares the row result with a range between 1 and 6 to make sure that the row is between 1 and 6. So let's go back to our Android Studio, and then then instead of this assert true, we want this assert true. All right. And then let's go back. Click the arrow next to the function and then run example test.generate numbers. If your code looks like the previous code snippet, your test should pass. Optional for extra practice, modify the dice for a 5-sided without changing the assertion to see the test result. Okay, so okay, with that, we do have an error here. Says make dice public. So it didn't mention this inside the tutorial, whether to make dice public, but let me see. So oops. So when we when we add the dice object, create an instance of dice, and so they created an instance of dice. Next roll, and then next roll they rolled it. Finally, make an actual assertion in other words. So this case, the value needs to be greater than blah 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 blah. All right. So it actually looks like it does not mention that they have that error with dice. So let me go ahead and see if we, with dice, if we can go ahead and do this suggestion, which is make dice public, which that makes it work, but I would suggest probably a temporary a temporary change just for the test because it's usually common practice for the classes to be private, but now it wants us to do public in order for us to be able to use it here. All right, so let's go ahead and go ahead and run this. So when we run the class, so we'll run all the unit tests inside the class here. So, boom, it passed. Great. So, all right. So that's basically the gist of what they wanted us to go over for today. And like always, I encourage you guys to go over the extra things such as the importance of testing, what a unit test looks like. Oh, okay, actually this is what we learned was the importance of testing, what a unit test looks like, how to run a unit test, some common testing syntax, how to write a unit test, and also if you want to learn more about testing apps on Android, you can reference this documentation as well, which testing is very important. So, as an Android developer, it's good for you to know this. However, not everyone will run unit tests and um, UI tests because it is writing extra code and an extra code base alongside your main code base, which some companies and um, some companies may not think it's worth it to maintain two code bases, the test code base and the main code base, and they um, fall back more so on the developers testing the app and the quality assurance team testing the app and trying to just squash bugs as they come up. But testing can be cool where it can probably also reveal um, bugs that may come up early instead of being finished and then finding the actual bug. But yeah, so congratulations there. And that's actually all that I have for you guys for today. Thank you so much for watching, and always stay coding. Please subscribe to the channel, post any comments or questions that you may have, and I'll see you guys next time. Thanks.